This is the screencast for Lesson 21 of Stephen's C# 24-hour trainer. The focus of this lesson was on using try-catch blocks to protect against errors. And for this try-it, we're going to look at this form. Here, the user fills in an item name, a price, a quantity, and then calculates total and clicks OK. There are a couple of problems with the form as it is. This is taken from Lesson 19, Exercise 4. And one of the problems is the user can enter some garbage in these fields like ONE for a number. The previous version of this program will just crash on that because it can't convert ONE into a number. One of the other problems is that the Calculate button and the OK button do pretty much the same calculation, and they duplicate code, so we'll fix that as well while we're in here. So here's the program written for Exercise 19-4. Here's the Calculate button. It gets the item name, gets the price each and quantity, uses decimal parse to turn those values into decimals. That's where we can get the problem with formatting. The OK button down here does the same thing. There's the item name, the price, the quantity. Okay? So first, let's take those common lines and pull them out of these two routines and put them in their own method. So to do that, you could just grab them and copy and paste them to where you want, or I'm going to select those lines. Those are the lines that are duplicated. Right-click, pick Refactor, Extract Method. So what that does is it takes those lines and it puts them in a new method. So let's give it a name. I'm going to call it Values Are OK. And let's see what Visual Studio did. It took the lines out of this routine where I had them before and replaced it with the call to Values Are OK. And then down here it made our little private void Values Are OK routine. So we'll add a comment here. Now I want this routine this method not just to get these values, I also want it to report on whether it succeeds or not. So I'm going to change this from a void method to a bool method. It's going to return true if the values are OK and false if they're not. We get a red squiggly underline because right now this does not return a value on all code paths. It means it's not returning true or false all the time. All right, in here is the dangerous code. These two lines right there where it uses decimal.parse are the ones that are likely to fail. So we're going to put a try-catch block around all of this. In general, I always like to catch the exception, at least in a generic sense, using a generic exception class here, so I can get the user some information about what went wrong. Let's take that code, we'll move it into the try block. Now down here, if we have a problem, I'm just going to tell the user that there's a problem. And hopefully the user will be able to figure it out. The most likely problem is going to be that the inputs to the decimal.parse were not the right format, and it'll just say something along those lines. Now, if we get through this part, we finish the calculations, the values should be OK, so we're going to return true. If we don't, we wind up in this catch block, we're going to return false. Now at this point, Visual Studio is smart enough to know that we have returned true or false on every possible path through this code, so our squiggly underline went away. All right, so there's our Values Are OK method. Meanwhile, back up here, the Calculate button calls it, but it doesn't use the return result. The way it's written right now, it's going to call Values Are OK, and then it's going to enable the OK button whether the values are OK or not. So we need to look at the return value from this thing. So we'll say if values are OK, then we'll enable the button. If the values are not OK, we'll disable the button. So now, when the user clicks the Calculate button, it'll check the values. If everything looks fine, the OK button is enabled. Otherwise, it's not. All right, we have one more thing to do with this method. If we go down here to the OK button, here's that other duplicated code. Well, now we have our routine to use to see if the values are OK, so we can call it instead of using this code. And the way we're going to want to use it is very similar to the way this button, the Calculate button, uses it. So I'm going to start by copying that code, come down here and pasting and get it into the OK button, and then just modify this. So the user clicks the OK button. If the values are OK, that's great. We don't need to enable the OK button because if the values are OK, this form needs to close. So how do we do it? We'll close the dialog. We're going to do it the way we close dialogs in general by setting its dialog result property. So we'll say this.dialog result equals OK. If the values are not OK, what do? Well, we'll disable the OK button. Okay, that part we can leave the same, and we will not close the form. Now there's one more little change we need to make. In the original version of this program, it didn't do any error checking on the OK button. It just assumed that everything was fine and closed the form. But if you remember the code that I just deleted, there was no code in here to close the form. So how did it do that? Well, the answer was, at design time, we set the dialog result property of the OK button to OK. And there it is. So what this means is when the user clicks the OK button, it automatically sets the form's dialog result. That closes it. We don't want to do it automatically anymore, so we're going to set this to none. So now when the user clicks the OK button, it does not automatically close the form. Our code has to do it. And that's in general the way you want to handle dialogues. And that's also why when you set a form's accept button, the form doesn't automatically set the dialog result property for that button to OK, because it's assuming that you're going to do some error checking before you close the dialog. So let's run the program and see what happens. Here's our program. We'll add an item. Let's add something that works. Pencil, price is 10 cents, quantity 12. We'll do our calculation. That worked. The OK button turned on. We'll click OK, and it's all added to the main form. Now let's try one that doesn't work. We'll try the feather duster. Its price is $5.74, and we want ONE of them. We click calculate, and it says the input string was not in the correct format. That's good. Hopefully the user can figure out what that means. Oh, there was one more thing in the requirements I forgot about. If there's an error, we want to set the focus back to the text box that caused the error. Now the way we have the code set up right now, this one try block captures all of these errors, and so we can't really tell which control was it that gave us our problem. So one solution to this is to break this up into a couple of different try-catch blocks and check each one separately as we're doing this parse. So let's do that. I'm going to pull this code back out of this try block, and we'll make a new one. All right, so item name equals item text box.text. That statement should work. This next one, however, is a parsing statement, so we need to protect it. So we'll put it inside there. Let me copy my message box up here. Now in this case, we know more precisely where the error is, so instead of using the generic input was not in the correct format, we can tell the user exactly what went wrong. There's a problem in the price each text box. So I'm going to change this message. I'm going to say invalid price each. And I'll still include the message from the exception because it gives a little bit more detail. Depending on your user, you may want to remove that message entirely. If the users are not very sophisticated, it may be kind of a scary message, particularly for some of the other exception messages that say weird things like parameter out of bounds and stuff like that. They're not going to know what that means. So if you can translate that into plain English, that would help them a lot. All right, so let's, and if there's an error, we want to get out of here and return false. All right, so now let's do the same thing for the quantity. We'll do a try, catch. We'll move the parsing statement inside there. I'm going to copy this message box and return statement and change this to invalid quantity. And again, we'll return false if there's a problem. Next, the program will calculate and display the total price. Hopefully those statements should succeed. And then finally, if the program gets this far, it means it hasn't encountered any errors, so we'll return true. All right, so let's try this version of the program. Let's try adding that feather duster again. For $5.74. We want ONE of them. If we do calculate, it says invalid quantity, input string was not in a correct format. That's a little bit better. We'll make it even nicer. After we display this message box, I'm going to set focus to the field that had the problem so the user can fix it. So here I'm going to say price each text box dot focus. And down here I'll say quantity text box dot focus. So now when we try to use this invalid value, it says invalid quantity, incorrect format. We close it, and focus goes right back there so the user can fix it. So now we'll do our calculation. And now, just to make sure this all works, we did the calculation correctly. Let's mess up one of these values. I'll put an extra decimal point in here and try to click OK. It's calling that values are OK method. It says invalid price each. Input string was not in the correct format. We click OK. Focus goes back to that control, and the OK button is disabled. So everything looks good.